Hello, everyone, and welcome. My name is Jesse Diaz, and this is my project, the Donkerhoek Bathtub. The Donkerhoek, which is Dutch for dark corner, is an origin-wide batholith in the Damara region of Namibia. It lies west of Namibia's capital city of Windhoek and east of Namib National Park. The batholith is a composite body that intruded into the low P sillimanite zone in the northern margin of the southern zone accretionary. The batholith is elongate, slightly sigmoidal in plane, and oriented parallel to the regional southwest northeast structural grain. It has a sharp and linear contact against the subvertical Okahanja lineament zone to the north, but more irregular and interfingering contacts with the folded and thrusted Kaisab formation that lies in the south. The batholith is located at the convergence of three cratons, the Congo, Kalahari, and Rio de la Plata craton. Here on the map, the batholith is encircled in pink. Now, some of you may be asking, what is a batholith? What a batholith is a large body of igneous rock formed beneath the Earth's surface by the intrusion and solidification of magma. It is a type of igneous rock that forms when the magma rises into the Earth's crust but does not erupt onto the surface. This solidified mass is then eventually exposed through weathering of the surrounding matrix and soils that surround it and results in a truly spectacular natural setting. Now, some of you may be more familiar with batholiths such as Half Dome or El Capitan, which are, you know, the main attractions in Yosemite National Park in California. Now, why did I choose the Donkerhoek batholith? Well, I've always wanted to visit the Namibian coast. There, one of the more famous sites is the Skeleton Coast, which some of you may be familiar with. Now, while doing some research on that, I discovered the batholith, and I thought the information that I found on it to be both interesting and relevant to what's currently being studied in this course. From a geologic point of view, it's important to know when and how the Donkerhoek batholith formed, because with an estimated minimum volume of more than 5,000 cubic kilometers, the Donkerhoek batholith is truly huge. It is the end result of the emplacement of an enormous amount of granitic magma into the mid crust. This batholith is the largest coherent mass of granite in the entire Damara origin. Now, the batholith itself is composed almost entirely of S-type granites. The main mineral within the granite is biotite. There is also a sporadic occurrence of magmatic minerals such as garnet, quarterite, sillimanite, and muscovite, which are all highly luminous. The published ages of the batholith and the surrounding southern zone area of the Damara origin are all highly contradictory. Extant geochronological studies suggest that these apparent contradictions may be due to different phases of the diachronous batholith having been in place over a protracted period of nearly 30 million years. Now, here is just one of two maps I'm sharing. Here you can see the location of the batholith. It is colored in with a dark orange, and you can see how it stretches across almost the entire origin here. Now, the different numbers on the map identify the different isokrads, and you can read that for yourself. Here is another map. Now, this map showing almost the same thing, geological map of the area, but here it shows that the entire batholith is composed of syntectonic Donkerhoek granite. Now, past studies have been done on the batholith, and they've included a variety of radioisotopic systems, such as the rubidium strontium system, the uranium lead system, and the neodymium samarium system. Now, the few published neodymium and strontium tracer isotope data suggest that a high degree of heterogeneity in the source terrain from which the Dunkerhoek granite magmas were derived, with whole rock initial 87 strontium 86 strontium ratios varying between 0.708 and 0.712, and epsilon neodymium varying from negative 1.8 to negative 8.0, which both having been calculated determining an age of 530 million years. Now, prior to 2017, geochronological data consisting of the uranium, iron, zircon data and some rubidium, strontium whole rock ages were limited and contradictory. Now, to measure the uranium iron system, zircon grains from within the granite were examined and used the laser ablation system. Now, the grains varied in size from 2 to 300 micrometers and were free of inclusions. Now, the zircon fractions can be distinguished by the uranium iron systematics, and many of the grains overlap and spread along Concordia, with apparent uranium iron dates ranging from around 570 million years to 530 million years. These past studies reported garnet whole rock, samarium, neodymium isochron ages at around 488 million years, and thermal ionization mass spectrometry, or TIMS, showing the 207 iron, 235 uranium ages 526 and 523 million years. Now, again, contradictory. Now, while these ages are only about 30 million years apart, they're significant since the 490 million year mark that the garnet samarium neodymium age does shows is that the whole unit is not syntectonic and it's actually late or post tectonic. Now, a more recent study done in 2018 by Schwark et al. Showed that the concordant data define an apparently older population with 206 iron, 238 uranium ages ranging from an estimated 570 to 530 million years. Now, this reconfirms the 2017 study by Clements et al. That the batholith is syntectonic and not late tectonic, and that it is the result of the emplacement of a massive amount of granitic magma into the midcrust. Since the rocks of the batholith are overwhelmingly S-type in character, this means that the mainly metasedimentary source rocks were heated and partially melted to create all of this magma. This in turn implies that the metasedimentary rocks must dominate the source terrain. Otherwise, the batholith would have contained more than the extremely small amount of I-type granitic rock that it does have. Now, to conclude, the data provided from the radiogenic dating of the Dunkerhoek batholith have confirmed its origin, but have brought into question the very landscape around it. Now, how or why are only certain of the Damaro origin formed from metasedimentary magma? And how exactly did this hodgepodge of continental crust form? While I am very much underqualified to answer these questions, many scientists and geologists are currently working to answer these questions. So hopefully, sometime in the near future, we'll get the answer to this and we can figure out just how that region of Namibia is truly formed. Well, thank you for joining me, and I hope you enjoyed my presentation. I look forward to any comments or questions that you may have on my post.